All right, so last time we had left off having just looked at the interest formulas. And let me put those back up for a moment just to remind ourselves where we were. There's basically two formulas that we're going to be working with, simple interest and compound interest. And we talked about how within a problem, it's usually pretty obvious which one we're asked to find if you're just deciphering the words that are used. So we're going to be looking for those keywords, those indicators when we're looking at the problems that we're working on. And we're going to take a look first at this one. So example 9, a company is expanding its line to include more products. To do so, it borrows $320,000 at 13.5% annual simple interest for a period of 18 months. How much interest must the company pay? So the first question you need to find out is, or answer for yourself is, which formula is he going to be using? Simple. Why? Okay. Just doesn't like blue. All right. Yeah, so it's got the word simple in there, right? We actually see simple. And that happens a lot in these problems. You actually see the word you're looking for, so look for it. So the simple interest formula we had from before looks like this. And it had another one that looked like this. And it makes zero difference which one you use, because all this is distribution, right? If you take this second formula and you distribute the P through, you get the first formula. So there isn't any difference. It doesn't make any difference. But we do need to identify which pieces of this information we have and what they're going to be put into the formula for. And then once we find that, we need to make sure we've actually found what we've been asked to find. Okay. So it actually asks us in this particular problem to find the interest, right? And that's really important because I don't have the interest on this particular problem in any of these variables. None of these variables is the interest part of it. Okay, so we'll talk about that in a moment. But let's identify what we do have. We've got this $320,000. What is this?
Principal.
That's my principal. Principal, remember, is either how much you borrow or how much you put into an investment. That's what principal is, how much you start with. All right, so my principal in this case, I tend to use this particular formula when I work, but it doesn't matter. You can use whichever one you like. It's $320,000. The next piece of information in my word problem is 13.5%. What is that? That's my rate, but in order to put it into the formula, it needs to be written how? As a decimal, and what's my decimal, Heather? You want it to be? Close. It's not 1.35. What would it be? 0.135. Remember, we would move the decimal 2 places to the left to turn it from a percent into a decimal form of that same number. All right, and then the last piece of information that I'm actually given in the problem is this business about 18 months. And 18 months is actually my time. But I mentioned last time that the time in these formulas is always represented how? In years. So if I put 18 months in, if I put 18 in, I've actually said 18 years. So what do I have to do? 1.5, right. So I will put the time in as 1.5 because 18 months is 1.5 years. Is everybody good so far? Okay. What will this actually find? What in the world is A? The total amount what? Right. So the A is the amount you pay back. That's a good way of describing them. So the A is the amount I have to pay back, which includes the original principal, $320,000. Yeah. Do they call it the balance? That's a good way of describing it too. So it includes the original amount that we loaned or borrowed in this case, right? $320,000 plus the interest. Okay. So let's figure out what this is going to be. Grab your calculators if you'd like. I'd like for you to simplify from the inside out. And I want you to do this on purpose because some of your calculators will cooperate with this and some of them aren't going to cooperate very well. So we're going to work on the inside first. So if you look at the inside the parentheses, this is the piece we start with. So I'd like for you to take 0.135 times 1.5. And then we work our way outwards. We add the 1. And your calculator will keep doing this, right? And then you times it by the 320, 320,000. What do you end up getting for A, the balance? 383,000, 84,800, even? All right. So this is the amount of the original loan plus interest. So that's not what I was asked to find exactly, right? I was asked to find the interest. So what do I do to find my interest? Yeah, I would take this original 384,800 and I would subtract the 320,000, the principal. What is the interest I paid for my loan? It's a lot of money, and in 18 months too, right? Wow, my goodness. They get you on the interest. $64,800 in interest. Yeah, it'd be a lot, wouldn't it? Okay. Any questions on this one? Okay. Second question. Johnny and Carolyn have 3 savings plans which accumulate to the following interest for 1 year. They have a passbook account that made $53.90 on a principal of $980. They have a CD that made $55.20 on a principal of $600. And they have a money market that made $158.40 on a principal of $1,200. Which account paid the best annual interest for 1 year? This is a little bit different question than the last ones, right? Because I actually know the interest amount, and I know the original investment amount, and what I'm trying to find is the interest rate. Is everybody with me? The rate that we're trying to compare. So let me show you how we approach this. We're going to take each investment one at a time, and what we're going to figure out is we're going to figure out what percent it is. And we can do it with proportions like we were talking about before class today. This is $53.90 out of the $980. And our question is, what percent of 100 is that? It's a proportion, right? Yes.
Did you turn all the fractions though instead of
Yes, that's another way of doing it. Yeah. Would you like me to do that on the next one so you can see it? Yeah. Okay. Let's do proportion on this one, and then I will go with Brendan's suggestion to show you on the next one. Okay. So if I do this one, I'm going to cross multiply, right? 980x equals 5,390. What interest rate is this? What is it? 5.5? Okay, so we have an interest rate of 5.5% on this passbook account. Okay, so let me show you another way to do it. But we're going to do number 2. Okay, so obviously we can do the same process on all 3 of these. Agreed? Yeah. Okay, so let me show you another option. Let's say we have this CD. This is $55.20 on a principal of $600. What you could do is you could take these 2 right here and use your calculator to divide them and simply multiply by 100%. Because if you take this ratio, this top divided the bottom, that gives you a decimal, not like the fraction you were referring to, I think, anyway. And then if you multiply by 100%, what do we get on this one? 9.2%. In essence, I did the same thing, right? I just did it in fewer steps. Okay, Brendan, is that what you were sort of thinking? Oh, okay, good. And then, how do you want to do number 3? Somebody just give me a suggestion. Which 3? Either of those options strike you as fun? Second one. All right, so let's do this third one, triple I, the same way we did the second one. So this is $158, 40 cents on 1,200 times, times 100%. What's my interest rate for the third one? Okay, so we need to make sure we answer the question because the question asked what? Which one paid the best annual interest rate? And so the answer is the third one. So the third one. Or we could say the money market. $13% interest rate. Okay, so let me ask the question a little bit differently. Why did we want the biggest one? Okay, we're making the most money because these are what? What are these accounts for? These are saving money, right? These are investments that we've made. These are money I'm putting aside. What if instead on all three of these have been questions about loans? I have 3 loans. I would want the smaller one if I were the borrower, right? Because a lower interest rate is better if I'm borrowing money, but the higher interest rate is better if I'm investing. Does that make sense? So you don't always just look for the higher or the lower. It depends on what you're actually finding. So be careful about the question and how it's asked. All right, let's try another one. Okay. Example number 11 says, a publishing company signed an agreement to allow a textbook, first edition, 500 pages, to expand over several editions to 1,000 pages. The textbook is growing at approximately 10%, and the number of pages over each edition. How many editions could be published before it reached the contractual limit? Okay, so this does not look like interest, does it? But it actually operates in exactly the same way. Okay? That 10% is acting like a 10% rate of something, because it is, it's a rate. It's just a rate of the book pages instead of a rate of money. So we can actually use the information done the same way. Now the catch is it simple interest or is it compound interest? Can you tell? Is it? Well, let me show you how to think about it without any of the formulas, and then maybe we can figure out which one it is, okay? And I think maybe that's how I did it last time, actually, even. So the first time we have this textbook, it has, so this is my first edition. My first edition is 500 pages. How in the world do I find out how many pages are in my second edition? Okay, I add 10%. So 50 pages, okay. So this time it would be 550 pages. And the way that we get that is we got that from 500 plus 50, right? 50 is 10%. What about my third edition? Okay, so why is it 55 this time, Devin, instead of 50? Yeah, I'm supposed to increase 10% of the size of the book that I'm working with. But I've got a bigger book now that I'm working with to increase upon, right? That's compound interest. Because you get interest on your interest. Here, we're increasing our page length based on our new page length. So, Devin's right, this is going to be 55 pages more. So it's my 550 pages I just had, plus 55 now. So I have how many? 605 pages. We'll continue this problem this way because this will work. My goal is to get to how many? 1,000. When I get to 1,000, I can stop this process. Okay? How about fourth edition? Well, I have my 605 plus what? Yeah, 60.5, right? So we'll round. We'll just use our rounding rules and say 61. Okay? If you round to 60, I'm not going to complain too much. So I've got 61 new pages, or 60 new pages. So I have a total of how many? 666. Uh-oh. We'll pretend we didn't see that. And then we go on to our fifth edition. So we have our 666 plus how many more? 67 for a total of 700 something. 33. Somebody better be checking me because I didn't have mine written
I think
down.
730.
Well, I can't do 7 plus 6 at the ending of 4, so is it okay? 733. Okay. 6th edition. Okay, I've got my 733 from before plus 73. How many is that? Is it 8? 806? Seventh edition. I have my 806 plus how many? 81. What is it? 887. Oh, we're getting really close. We're almost done. Alright, we're getting close to 1,000. 8th edition. I have my 887 plus how many more? 89. $9.76. Okay, it says how many editions could be published before it reaches the contractual limit? 8, right? Because if I get one more edition, I'm over 1,000. And I'm supposed to have a limit of 1,000. So it can have 8 editions. Yes.
I thought it was only compound. So
You can have annual compound interest in every one.
what makes that different?
The formula works differently. It just works out differently. Simple interest means that you compounded it one time.
So what if you have an annual rate?
The annual rate is just how the rate is determined. It's not how the interest compounds. You see, when anybody gives you a rate for interest, not always, but generally they're giving you an annual rate anyway. For instance, when you go and you get a car loan, they give you a car loan and they give you a rate of 5%. They call it APR, annual percentage rate. But that doesn't tell you how it compounds. That just tells you what the annual rate is. It's tricky.
So every
This
every
one's compound.
interest rate is really
Simple interest rates done differently. Simple interest means that they charge you the interest on the initial amount of loan one time. So they figure out the interest amount one time and then they divvy it up across how many payments you have. So that's different. That's the simple interest means that they found the interest only once and then they divvy something up. Yeah. All right, I think we've got one more. Simple interest does not build upon itself. No. Right. Exactly. Yeah, so like if you were being charged simple interest, it would probably be a situation like somebody loaned you money, like a friend or a parent or something like that, and they're sort of wanting to teach you about this whole idea of interest, you know, that the borrower actually is paying more back kind of an idea. Well, they don't usually want to sit down and figure every single time on the loan that you pay how much interest you have left. They'll usually say, oh, I'm going to give you $5,000, I'm going to charge you a 10% rate, and then you're going to give me $500 back, and then we're going to sit down and figure out, oh, over the course of 2 years, this is how much you pay each month. So simple interest compounds doesn't compound the interest, it figures the interest one time, and then you divide it out across everything. Yeah, like a payment plan. But if you do compound interest, you can still have a payment plan, but they figure the interest every single time they charge it for you. They refigure based on how much you owe now. It would not necessarily raise, but the amount that goes towards your principal pay down versus how much you pay towards the interest changes over time. Yeah. All right, one last question, example 12. I think it's the last one, isn't it? Yeah. Because of a recession, the value of a new house depreciated 10% each year for 3 years in a row. Then, for the next 3 years, the value increased 10% each year. Did the value of the house increase or decrease in 6 years? Explain. So, sort of inherent to the way the problem is worded, it's not the same. It's not worth the same amount, even though it sounds kind of like it should be, doesn't it? It increased 3 years 10%, it decreased 3 years 10%. Doesn't that just sort of balance out? And the answer is actually no, it doesn't. So, we're going to take a look at this in the same way that we just did that last one with the textbook problem. Okay? But what we don't know in this problem is actually what? The amount of the house. We don't, right? We're going to make something up because that's actually going to be independent of the rest of the results. So I'm going to make up an amount of a $100,000 house because $100,000 is easy to work with. Sound good? And it's a reasonable number, right? I mean, like that's actually an amount of a house. Kind of, it's reasonable. All right, so we're going to say that the house is worth the original amount is $100,000. And we're going to find what it's worth after 1 year. So 1 year later. So this one says it's supposed to depreciate 10%. So if it was worth $100,000 originally, what does it mean to depreciate? It's going to lose value. It's going to lose 10%. What is the 10% of this number? $10,000. So I'm losing 10%, the $10,000. So how much is the house now worth? $90,000. It's after 1 year. Second year. Now I'm starting at $90,000 and I'm losing again 10%. What is 10% of $90,000? It's what?
900.
It's 9,000.
Oh, 9,000.
9,000.
Sorry,
One decimal off. It's
I
okay.
wrote that down.
Okay. So that gives me what? $81,000. Great. Third year. One more time I'm going to depreciate, right? So now I'm at 81,000. How much am I going to lose? 8,100. So how much is it going to be worth? Might want to grab a calculator. You don't have to, it's not hard, but what do you get? Something. 72,900. And this is exactly the problem when you borrow too much on a house. It's because it doesn't always go up in value, right? You can lose money. It happens to lots and lots of people not too long in the distant past. Okay, but fortunately, it's going to rebound. The market has come back up apparently, and for the next 3 years, it's going to increase 10% every year. But we're still starting at this $72,900. How much am I going to add to this now? 7,290. So after my fourth year, what's it worth? Okay, did that add up? Did we get that? Sounds good to me. All right, we're going to do it again. Now we have got a house that's worth $80,190, and it's going to increase another 10%. So how much will it increase by? 8,019 for a total of what? $200 what? 209. Good. One more year. This is our 6th year. We have now an 88,209. What are we going to add to it? We'll round to the nearest dollar. That's fine. So we'll go 21. All right. So what does this give me? 96 or 97? I have 97 written down. 97,030. Work. Okay, so compare. Did the house gain or lose value? It lost. Now, we want to be careful. I don't want to say it lost $3,000 because I made up the number of $100,000 from the cost of the house tonight. It wouldn't be good to say that it lost $3,000. But it lost $3,000 roughly out of the original $100,000, which is about 3%. So, and we could figure that out again using the same percentage formulas that we've done before. I could take that 97,030, I could write it over my 100,000. I could either multiply by 100 or set up a proportion to find out that this ends up being roughly 3%. It's actually, yeah, 3% is exactly what I have written down this to the nearest percent. 3% loss in value. But if it keeps going and it recovers one more year, that 10%, then we're okay, right? But it took 7 years before we actually are back to the up in the house. Any questions on that one?